All right. Simplifying radicals. You may have done this before. I'm not sure.
Mansfield.
Possibly in Mansfield. This is a fun thing because we're going to draw trees. What type of trees? Math trees, the best one. Snowflake trees. I'm all about nature. Okay. Moving from one to the other. Okay, so here I have this radical, and it's radical 32. Do you see that?
Yes.
It's pretty crappy copy, so 32 didn't come out very clear. And if I look at my calculator and I do the square root of 32, it does not give me a very nice number, does it?
No.
That is pretty ugly. But it's 5.65685, blah, 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 blah. I kind of want to keep that vision in my mind a little bit because I am going to simplify this to something that's going to equal the exact same thing.
What?
You ready? In fact, let me do it on my, I don't even know where it is, my graphing calculator, so I don't have to clear it so you can actually see what I'm talking about. So, I promise there's a method to my madness. So, there's the square root of 32, like I just said. Yeah? Okay. Now, I'm going to take 32, and I'm going to draw a tree. That's the start of my tree. Sorry. And I need two numbers that multiply to get 32. 8 and 4. Okay. I'm going to keep going until I have prime numbers. And once I hit a prime number, I'm going to circle it because I know that's the end of that branch. Okay. So 8, two numbers that multiply to get 8. 2 and 4, 4 and 2, doesn't matter. Are either of those prime?
No.
The 2 is. So I'm going to circle it. 2's done. Can't go anywhere from there. 4 is 2 and 2. And this 4 is also 2 and 2. So there are no branches that can keep going, right?
Nope.
Okay. So here's what we've got. We've got our little radical house. It's a really rad house.
I like that house.
But in order to leave the house, you have to have a twin or a buddy. So in other words, these two 2's, they can leave.
But if you cross out 2 2, why are you putting 1 2?
Good question. If you cross out two 2's, why are you putting 1 2? Because that's really, all of these numbers are technically under that radical, right? And so that's really the square root of 4. 2 times 2? And what's the square root of 4? 2. So I'm really taking out a rad 4, if you want to think about it that way. So there's a 2. This is another 2. And I'm going to multiply it by that guy. And then there's one loner that has to stay at home. See? Nobody. So he stays at home.
Okay.
I would be okay.
So what do I have here? 2 times 2 outside. And 2 inside. 4 radical 2. Now watch this. When I go to my calculator and I press 4 radical 2, what do you notice? It's the exact same answer. This is just the simplified radical.
Wow, that's interesting.
Ooh, I like it. Okay, so that's what we're going to be doing here on the front side, is just drawing these trees. Okay? All right, what about this one, 112? Now, when you get to larger numbers, don't be scared. Okay? First thing I think about is the fact that that is an even number, so I know I can divide it by 2. So I would go to 2, and I would go to my calculator because I don't trust my division skills, and I would get 56, which is still an even number, which means I can do 2 again, can't I? You can. If you want to do 8 and 7, that's fine. What will happen is at the very end of the problem, you will have the same amount of 2's circled and the same amount of whatever other numbers circled. You'll have the same thing. Okay? 28, I know that is what? 7 and 4. 7's prime. Okay. Sorry, I just had to plug in my iPad. So if you chose 2 different numbers, as long as they do multiply to get 112 or 56, whichever level you're on, you should end up with 4 2's and a 7 circled. Okay? So it doesn't matter what order, just you'll end up in the same place. So let's talk about who gets to go and who has to stay. Who gets to go? I have a 2, that guy gets to go. I have another 2. And who's got to stay?
7.
The 7. So what do I have? 4, rad, 7.
Why would they want to leave the rad house?
Why would they want to leave the rad house? That's a good question.
The house
I don't
is
know.
pretty rad.
If the house is rad,
They lose their radness when they're not unique. Ooh. Think about that one. Okay. 72.
36. They're not rad anymore.
2 and 36. Or 9 and 8. Go ahead and do 9 and 8 and see that you end up with the same numbers as I do. 36 I know is 6 and 6. 3 and 2. 3 and 2. And all my branches are ended.
Oh, so there's 2 3s.
What was that?
When there's like 2 of any number, you just put that number, right?
Basically. Yep. So let's see. I have a 3. That guy can leave. The 2s can leave. And then the loner 2 is stuck at home, so I have 6 radical 2.
he's not a loner. He's just antisocial.
That's true. He's proud of his uniqueness.
Exactly.
So you only get to be in the rad house if you're a loner.
That sounds so
That's like a in a
sad.
rad house.
All right. Why don't you try number 4?
Okay.
It looks
I
good.
told
It's even. So what does that mean?
About that, you could buy that too.
Divide by 2.
Yeah.
Hi, Ocean.
Mario.
Renee, get on. That was mean.
Why are you kicking me? What the hell is
I
that?
can never feel
What
good.
the-
6 and 2.
Sorry, Ocean.
Nothing. No way.
What if there's 3 3s?
Then you have a loner and a pair.
Oh yeah.
2 2s and 3 3s.
So 3 is the only one.
So let's see. I think I have a 2 outside and a 3 outside. Yeah? And a 3 inside, so I have 6 rad 3.
Dang, how'd you do it so fast?
Because I'm a genius. Just kidding. JK. Now, out of curiosity, hold please. Okay. What if I'm in issues there, don't mind me. Okay, I'm going to change number 5.
Oh, why?
Dang, a whole big
Divided by
It's not even, but it ends in a 5, so I can divide it by 5. 5 times what? 225 divided by 5 is 45.
Oh, wow, that went down a lot.
Uh-huh. 45 is also divisible by 5.
That's 5 to 5.
Uh-huh. So when you have these big numbers, within the first step or two, you're down to much more reasonable numbers.
Yeah.
And then 9 is 3 and 3. Now, I wanted to show you this one because what do you notice about my numbers here?
So there's no, what's it called?
There's no loners.
Yay.
So there is nobody left in the rad house. So what does that mean?
There's no good.
5 times 3 is,
15.
and there is no radical with it. What that means is 15 squared is 225. 225 you can take the square root of.
I love that.
Okay? All right, you try the last one and then we'll turn the page.
Dang, 175.
It ends in a 5, so what can you divide by? And you should get down pretty low from there.
Bless you.
Gesundheit.
Thank you.
Oh, that one's easy.
Yep.
Is it?
Yes.
No, it's pretty easy.
5 rad 7. Ask your question.
Wait, so the loner goes inside, right?
The loner has to stay in the rad house.
So like,
I haven't done this since like 4th grade.
And so if there's
Because when you have a twin, you lose your radness.
Which one goes in?
Oh, wow, that's
Oh, wait, never mind.
The loner goes inside.
I got it.
you're not rad.
The pair
Parents kick you out of the house.
goes outside.
the loner.
Okay.
And we all know this is a fictional story. I'm just making up to make it work, right?
Yeah, that helps a
I
lot.
thought it
So
was-
if any of you are twins, I'm not trying to offend you, okay?
I know she said
My best friend's a twin,
I
actually.
thought it was a real-
Fraternal or identical?
Fraternal.
My best friend is a fraternal twin.
I wish I had a twin, but then people have that.
Okay, we ready for the backside? Good answer. Okay.
This looks too hard.
I apologize for the lines. The copy machines are going crazy right now. They're being weird. But this side is a little bit different. Well, actually, it's a lot of bit different because there's no radicals
A lot of it.
and there's equal signs that kind of look like minus signs because the copier stinks. Yeah?
Yeah, I get it.
I'm not gonna shoot anyone.
Okay, so what I need to remember on these guys is I need to get whatever is squared by itself. So in this problem right here, in these first two, I actually have it already by itself. Do you see that?
Uh-huh.
Okay. Once it's by itself, if I want to find out what n equals, I have to get rid of that squared. How do you think I cancel out a squared? You take a square root. Square root cancels out a squared. Now, I do need to remind you of something, because when you take the square root of something, there's not just one answer. Now I'm really going to blow your mind. There's actually two answers. Because let me ask you this. What is the square root of 9? And negative 3 is also the square root of 9. So there is always a positive and a negative number that is a square root. The reason why that is, just to get those of you that are still a little bit questioning, the definition of the square root of 9 is you're looking for the number that when you square it gets you 9. That's the definition, right? There are two numbers that could go there. Yes, 3 could go in there, but also this is just as true of a statement, which is why there's two answers to it. So every time I take a square root, I have to use this little symbol right there, which means plus and minus, meaning that I'm talking about both situations.
Isn't it plus or minus?
Plus or minus, yeah.
Didn't you just say that?
Radical 54, or and, doesn't matter in this case. Okay? Now, I see a radical, so what do I need to do?
Oh, the tree.
Draw a tree. So I'm going to draw a tree. 2 and 27. I think I did this one on the other side, didn't I?
I don't remember a 27.
Oh, I do. I remember 54. Somewhere. Right there. Number 4, I ended up with a 54. Anyways. 3 and 3. So, my answer is going to be n equals plus or minus 3 comes out. What's left inside? 2 and a 3. So what do I do with those guys?
You multiply it.
You multiply them. And that's what my answer is going to be. Now, that's technically two answers. It's
Yeah.
positive 3 radical 6 and negative 3 radical 6. That's all we're doing here.
Yay.
Okay? Let's try this guy. Is the thing being squared by itself?
Yes.
All by itself, nothing else on that side of the equals. So I can square root, and what do I need to remember when I put the square root in there?
The positive and the negative.
So I have n squared equals plus n minus radical 43. Can I draw a tree for 43?
I don't know.
Why did you add this blue?
21 goes into 42, not
You're getting rid of the
43.
square. You're getting rid of the square, and you put a square.
I didn't mean to put a squared. Good eye.
That's it.
Way to catch the teacher. We'll pretend like that doesn't exist. See? It was never there.
It's a brighter white than everything else.
43 is a prime number. I can't draw a tree for it, so I'm just done there.
Interesting.
How do I know that?
How do you do it?
Lies.
What do you mean, how do you do it?
That's the answer, man.
That's my answer.
How do you know if it's a prime number?
You can't draw a tree.
Well.
There's no two numbers that'll multiply to get it. So you can sit there and think, let's see, 43 divided by 2, 43 divided by 3, 43 divided by 4, 43 divided by, it's not going to divide by 5. You can keep trying a few, and once you get up to like 10 or 11, if you're still getting decimals, then you can pretty much assume it's prime. Okay? Good question, though. All right, this one, I'm adding a step to it.
Oh my goodness.
What step am I adding?
Add 5. I mean, the 5.
Thank you. We have to add 5 to both sides because I need to get that k squared by itself. That gives me k squared equals 36. And now what?
You square root.
Square root, remembering what?
Yeah.
Plus and minus. Do I need to draw a tree for 36?
Yes. I mean, you don't have to.
I could draw a tree, or I could just remember that the square root of 36 is 6, and that's what I'm going to get from the tree if I were to draw the tree. Right? 36 is 6 and 6, 3 and 2, 3 and 2. So 3 and 2 come out and nobody's left at home. That's where the 6 comes from.
Okay.
Capiche? What about number 10?
Don't you have to like get rid of the negative? I mean, you multiply.
I got to get k squared by itself, so I got to get rid of that 5. How do I get rid of it?
So you divide it.
Divide both sides by what?
Negative 5.
-5. Now, some people will have a tendency to divide by -5k squared. They'll keep the k there. I don't want the k to cancel out. I just want the -5 to cancel out.
54.
So let's see. K squared equals... Is it really?
Yeah.
Divided by -5 is 54. So, I'm going to square root both sides, remembering what?
The positive
Plus and minus. And k equals plus and minus. Now, I'm going to save myself a little time because I already did a tree for 54
Yeah.
right here. Remember that?
Mm-hmm.
So, it's going to be 3 red 6.
Yeah.
Could I do the tree again?
Yeah.
Absolutely. You're doing the same problem you already did, though. Save yourself some time. Okay? All right, this is about as hard as I can make it.
Oh my gosh.
Ready? What do I do?
So try 6.
Subtract 6. You did problems like this in IM1. You just didn't have the squared with it in that last step, right? So that gives me 49 n squared equals what? 16. Now this one's a little messy. Because does 16 divide by 49 nicely? Does 16 over 49 reduce?
Yeah.
16 over 49? Nope.
Really?
Okay. But what do you notice about 16 and 49? Do you notice anything about them?
No.
No? Okay. So I have n squared equals 16 over 49. When I take the square root here, and I remember my plus and minus.
You're taking a square root of a fraction?
I know, what kind of crazy is that? Can I take the square root of 16? What is the square root of 16? 4. And what's the square root of 49?
7.
So guess what the square root of 16 over 49 is?
4 over 7?
Yep.
Oh my gosh.
Genius.
Yeah, I don't like that one either. That's a weird.
So you can take the square root of a fraction and, well, yeah. And what's nice is when your fraction, when both numbers, the top and the bottom, you can take the square root of, then it actually comes out fairly nice. Okay? All right, last one. What do I need to do?
You subtract 3.
Subtract 3. Because what am I trying to do? Get x squared by itself. So we're just going to start moving stuff over. Negative 447 minus 3. Negative 447 minus 3. Make sure you're going the right way to get negative 450. Now what?
You divide 10, negative 10.
Divide by negative 10 on both sides. That gives me x squared equals
The right answer.
45. So now what do I need to do? Square root, remembering plus and minus. So x equals plus and minus. Let me draw my tree for 45. 5 and 9. 3 and 3. Who comes out? the 3,
And the five.
and the 5 stays in there. Now, please do not get this confused with 3 plus or minus rad 5. Some people will want to write their answers like this because they've seen something that looks like that before. The plus or minus comes before anything you're taking out of your radical. Okay? So please don't get that confused. Not too bad?
Happy study.
Happy studying.